connection between binary exponentiation and Horner's rule. In this video, we want to understand the relationship between these two things, binary exponentiation and Horner's rule. So we're familiar with the Horner's rule, but how do we use Horner's rule, take advantage of the efficiency of the Horner's rule to help us get an efficient evaluation of a to the nth power? Yeah. All right, so here first, in order to represent a to the nth power efficiently, the first thing, we need to represent n in a special way. So this special way, when we write it as a binary representation, base 2 representation, we can interpret it as a special polynomial p at that x equals 2 point, at one special point, x equals 2. Yeah. So that is the special view change. Why we want to represent in this special way? The reason is very simple. The reason is only when you use this special structure, you can apply Horner's rule. You can take advantage of Horner's rule efficiency to calculate a to the nth efficiently. How can we do that? Yeah, how can we do that? So here, let me get there step by step. Yeah. All right, first, this is the Horner's rule way, special way to do the multiplication. Yeah, so we're familiar with this. Okay. Yeah. In this way, we can get extremely fast evaluation. Yeah. Similarly, if we replace x by 2, then we hope we can enjoy the same fast efficiency. All right, so now let's get to our real problem, from Horner's rule to binary exponentiation. Yeah. Connection. First, when we evaluate a to the nth, so we can write in this way, right? First, yeah. This way, when we use base 2 representation, it corresponds to repeated squaring, right? Repeated squaring. Yeah. We're familiar with that technique. Yeah. So in our first view, first try, let us look at this through repeated squaring way. So not the Horner's rule way, repeated squaring way. So here it's different. Horner's rule way different from repeated squaring way. Okay, repeated squaring way. Different. Okay, all right. How different? So let me use this general element. Okay, yeah, I treat this as a general element in the whole multiplication, whole product structure. This general element, b sub I times 2 to the ith power, use that as the exponent of a to the certain number power. Yeah. And with this structure, definitely we can apply repeated squaring. Okay? Yeah. How? Yeah. So let me look at this general term. For that general term, we know b sub I can only take two possible values, 0 and 1. Binary, the bit value only 0 and 1, right? When b sub I equals 0, the whole term is just 1. Multiply 1, we do nothing. So that's the easiest case. Do nothing. Yeah. So when b sub I equals 0, that's, we can look at the next term, right? Yeah. So this term, nothing to do. Yeah. But when b sub I equals 1, then we get the special form that corresponds to repeated squaring. That's the repeated squaring way to get its value, right? Yeah. Yeah. So that's how we use repeated squaring to calculate a to the nth. Yeah. All right. So you can see the first case, no multiplication. Second, we need to use square operation. Yeah. So now the question is, this repeated squaring based calculation is still not the most efficient way. Not the most efficient way. Why? Because for each term, you need to do repeated squaring, right? Squaring every term, term by term, okay? Independently. Although you can store certain repeated squares in some temporary locations, but still, overall, you waste a lot of multiplications. Yeah. So that's something we need to understand. Yeah. So to avoid that many wasted number of multiplications, we need to take advantage of Horner's rule. Horner's rule, we know we can combine many terms and try to explore their common factors so that we can reduce the number of multiplications. That idea is important here. Yeah. All right, so now let us write our a to the n in the Horner's rule way. Yeah. So this time, we organize those bits based on the Horner's rule special arrangement. How about that? So you can see it's different from that, independent way to handle different terms. Independent way. So here it's a, combined way. Yeah. So the new way can save us a lot of multiplications. Yeah. But the next question is how to organize data. Yeah. When we take advantage of the special structure based on the Horner's rule, how do we arrange our data to support the calculation? So that's the question. Supporting the special calculation. Yeah. All right. Yeah. So that's our next topic. Okay. Yeah. So now we get to this critical point. Yeah. But before I explain the implementation part, I want to introduce a new and important concept. In my next video, I will use 2 videos to explain a very important concept called a decision tree. Decision tree concept. All right, so let me stop